Hello there. I've been doing some reverse engineering of Star Wars Knights of the Old Republic, and I've been working on this function here called inDoor. What this does is it takes a reference point, usually the point of a player, and it checks to see if it is in the transition area of a particular door object. This is very interesting because from a speedrunning background, we have identified a glitch with this we call the DLZ, in which if you're standing exactly X-aligned with one of the edges of a door or trigger in the negative Y direction, you will activate it remotely. So I'm going to walk us through the code and explain why that happens. First of all, let's get a general understanding of what this is doing in your average expected cases. So this black rectangle here that we have, we're going to call this our door area. It has four corners in each of these edges, and we're going to number them 0, 1, 2, and 3. So you can remember that just clockwise, 0, 1, 2, 3. So in your ordinary operation, let's say the player was standing right here inside the door area. What this code does is it takes this player point and it draws a line directly up. Then what it does is it takes each pair of corners going in order. So 0, 1, 1, 2, 2, 3, and 3, 0. And it checks to see if this line we drew straight up intersects with it. Clearly, by looking at this visual, it's going to intersect with the 0, 1 line one time. And what it does is it just counts the number of intersections that you get. So if you get an odd number of intersections, you are inside the door. However, say your player's down here, and it again draws a line straight up, you will see that it gets an even number of intersections 2 times. And that will indicate that it is outside of the trigger area. And it works the same way for any polygon, not just rectangles. If you get the odd number of intersections, then you're inside of the trigger. And if you get an even number, you're outside of the trigger. So that makes perfect sense. However, it will start to beg the question, what happens if our player is exactly on the edge? Well, if you draw a line straight up, you are going to be exactly with this line and intersect these points exactly. So there are special edge cases you have to take care of to avoid problems there. The issue is the devs did not do a great job of dealing with those edge cases. So first of all, I'm going to draw a little axes down here. So this is going to be our positive x direction, and this will be our positive y direction. And now let's suppose, like we drew before, our player is here at a DLZ point. That is, its x is exactly aligned with the edge of our door, and its y is in the negative y direction, so pointing opposite to that axis. So let's jump through the code. We start with this incrementing variable being 0, and we start with 0 intersections. The intersections are important, so we're going to keep track of those. Joink and joink. We have 0 intersections, so I'm just going to use tally marks for that, so right now I'm leaving it blank. So prev is going to be equal to this corners. So what that is doing is it's just in C, if you just set a pointer directly equal to an array, it's just going to give you the first value in that array. So it's saying that previous is equal to this corner right here. Now we enter into our do while loop. So this loop, I'm just going to show you the bottom, is going to go until that incrementing variable is less than this special number right here. If you're curious what that special number is, it's usually 4. I guess it's the number of corners that the door has. It seems like at some point there was an intention for there to be doors with more than 4 corners, but it seems like that never happens. So this is, for all intents and purposes, it's just saying for each corner that this door has. I believe the reason this value exists is because this code was cannibalized from the code for checking if you're in a trigger, which triggers can have as many corners as they want. Anyway, so yeah, our previous is this red X here. Now what we do is, this is checking to see if we've hit the last corner. We have not, so it gets ignored. Otherwise, var2, which is our other incrementing variable, is just going to be 1 greater than var1. So that means when we do corners at var2, our current, which is we mark with cur, is going to be the second corner over here. So that is corner 1. Now that we have that figured out, so this looks kind of complicated, and honestly it is. It's kind of silly that they coded it this way. This NaN operator is just checking to see if this is not a number. That can happen if you have some weird floating point error. It is not going to happen, not in any of these cases. So for all intents and purposes, these will always be false. So this is saying, is false equal to this over here? Current x, so that is the x value of the green check mark, equal to the previous x, the red check mark. That is false. False is equal to false, so we enter the if statement. This pointer is just going to be pointing to the y value of our current corner. So that is this y value up here. And delta y is going to take that and subtract the previous y value. Since they're at the same y, that delta y is going to be 0. Meanwhile, delta x is taking the current x value minus the previous x value. So it's going to be a pretty big number, right? Because there's a big change between those. Now, what we do here is we grab the y-intercept. So this is where we're doing the draw the line straight up. It's trying to figure out at what y value we will have an intersection if this line went on forever. So what it does is it takes the slope, change in y, over change in x, which we notice our delta y, or change in y, is 0. So all of this gets zeroed out, and our y-intercept is just the y-coordinate of the previous y. So that is this y-coordinate up here, which they're the same y. All of this is the same y-coordinate. Now we're checking to see if the point is below that y value, and clearly it is. It's well below that y value. So we take the absolute value of delta x, and now we're saying, is the change in x less than the change in y? No. Is that equal to the not a number status? Well, this is also false. False is equal to false, so we jump into the if statement. Now we're saying, is the current x value, that's the green x value, less than or equal to the previous x value? Well, no, it's much greater, so it takes us down to our else if. Now we're saying, is the previous x value less than or equal, and this is where the devs made a mistake, to the x value of the point? Well, it is. It happens to be exactly equal. Now in here, they do a strict comparison with the current x value. So is the point at x directly less than the current value at x? Well, that is true. And is true equal to false? No. So this Boolean variable right here is false. And now we have a goto, so we just jump down to that label. So we got false out as our result here. Well, not false is true, so we add 1 to our intersections. So let's add a tally mark. So there's one intersection. So I suppose that makes sense, I guess. We draw a line straight up from here, and they say, okay, I guess that intersects. But after we get that intersection, well, actually, no. So after we get that intersection, it takes us through all of this, and we jump down to this if statement here. Again, we're checking not a number. That will be false. Checking, is the current x equal to the point at x? That's also false. We're asking, is false not equal to false? It's not, so we skip this if statement. Now we increment our incrementing variable, and when we do prev plus prev1, this is pointer arithmetic. So this is basically taking us to the next corner. So let's jump back around. I'll do some, wrong button. Quick and dirty erasing. Joink and joink. So now our previous is going to be here, and our current is going to be here, which should be clear by this incrementing that happens. So we're saying, is the current x equal to the previous x? They are the same x value, so that means this equals false, which means we jump all the way down here, and we're checking, okay, false and false. Now we're saying, is the current x equal to the point at x? It is not. So this also shows up as false. So we're saying, is false not equal to false? No, so we jump past. It takes us to our next value. So boop, 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 boop. Next, we have the previous is here, and the current is here. We roll back around to the top. So is the current x equal to the previous x? No. We have our delta y is going to be 0. Our delta x is going to be some large negative number, but this all gets zeroed out regardless. So the y-intercept is going to be at this y level here. Now, point y is still less than that y-intercept. Now, delta x, which has been taking the absolute value, so now it's a big positive number. Is it less than delta y? No. False is equal to false, so we jump in here. the current x value, so that's the x value, the green check mark, is that less than or equal to the previous? It is. So it takes us in here. Now we say, is the current x value, so the green x, strictly less than the previous x value? It is. And is it strictly less than the point x value? It is not. So that takes us out of this if statement. Which takes us to here. The else if's been discarded, takes us to here. This else if's been discarded, takes us to here. We already can't do this else if either. So it takes us all the way down to here. Now we say, so this is all false. Now we're saying, is the current x, so the green x, equal to the point x? It is. So we jump to this next part. Is the point y less than the current y value? It is. It's also less than the previous one, so either of these would have done. So we get another intersection from this. So we go joink, that's 2 intersections. Now we're on to our next step. So jeep and blup, cross those out. So now our previous is here and our current is up here. And we rush around, this is going to be our last iteration. You'll notice that at this point, if you're keeping track, ivar1 would have been equal to 3 at this point, which is causes this, which means that ivar2 ends up being 0. It rolls back around, which is why we managed to get the corner 0. So here we go. Is the current x equal to the previous x? It is. So we have to jump all the way down here. Now we're saying, is the current x equal to the point at x? It is. Is the point at y less than this previous y? It is. We add another intersection. And I'm sure people who've kept up at this point say, uh-oh, that doesn't seem right. We do all of these. At this point, ivar is no longer less than this value, so we jump down here. This is a bitwise AND operator. I know this looks complicated. It's actually very simple. So we have this number 3. If I were to write this out in binary, it'd be like a bunch of zeros and then 1, 1. That's our 3. And it's saying we are doing a bitwise AND with this value, which if you look at the binary for it, don't worry about that first bit. It's not important. All we care about is that last bit, which is also just a 1. So what we're doing is shoot. If you take a bitwise and 1 is going to give us 1, 1 and 0 is 0, and then the rest will be zeros. So all of that's to say that we basically check to see if this is odd or even, and it says, okay, it's an odd number. So now intersections is set to 1. Don't worry about this nonsense. That's just a check for weird negative possibility. Is 1 not equal to 1? That's false. 1 minus 0 is 1, which if you cast that to a bool, you get true. So all of that to say, despite this P point clearly not being inside of this door trigger, it is still satisfying all of the requirements for this indoor command to return true. I realize that was a little convoluted and not the best graphics. Let me know if this made sense or not. But yeah, this is essentially why DLZs happen with doors. Another thing to add is as I get more in depth on how these corner values get set, we will have a pretty decent path into calculating the exact x coordinates for door DLZs, which has been something we've struggled with in the past. But yeah, that's about it. Let me know if you have any questions, and thanks for watching.